So hello friends, in this video we are going to see what is a gradient operator. So a gradient operator is a mathematical operator which when operates on a scalar function. So a scalar function is a function which takes a value as input and gives value as output. And a vector function is what? It gives vector as output, though it takes a value as input. So here this gradient operator is a mathematical operator which when operates on a scalar function it gives a vector function. So when gradient operator operates on scalar function it gives a vector function which assigns a vector to each point on the curve of scalar function. So we get a vector at each point of scalar function. So what is the significance of this vector? So the magnitude of this vector at that point gives us the maximum rate of change at that point. So why maximum rate of change? Because for functions like functions of two variables, three variables, uh, the rate of change can be different in different directions at a point. For a simple function like y is equal to x square, we have the total derivative. But for other functions like multivariable like f of xy is equal to x square plus y square, we do not have the total derivative at a point. So the derivative changes as we move around that point. So this vector will always point to the direction where there is maximum rate of change, and its magnitude will give the maximum rate of change at that point. So the expression of gradient operator, so first of all the gradient operator is denoted by this symbol. This is called as del. So it is also called the del operator or a gradient operator. So its expression is like this: del by del x I cap plus del by del y j cap plus del by del z k cap. So these are partial derivatives. So when it operates on a function, we have a scalar function phi. So to operate it on phi we must multiply the gradient operator with phi. So we will get the gradient of this function as this expression, which is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So this is partial derivative of this function with respect to x. So first of all you must know partial derivative. In partial derivative we take the derivative of a function with respect to a given variable by treating that variable as a variable and all other variables as constant. For example, if we have a function f of x comma y uh, is equal to x square plus y square. So if we want to take partial derivative of this function with respect to x, then we will treat x as variable and y as constant. So del f by del x is equal to 2x, and y square is constant because y is constant. So 0, that is 2x. Similarly, if we take partial derivative of this function with respect to y, then it will be 2y because x square will be treated as constant. So this is about partial derivative. So now we will see how gradient operator operates on this function phi, and it gives a vector function which assigns a vector at each point, and that vector points in the direction of maximum rate of change at that point. So we will verify is this definition really correct, or is this definition really meaningful and useful. So we will see here. So we have a phi function phi is equal to x square. So when we take the gradient of it, that is the gradient of function phi is equal to this expression which we saw earlier. So we will get this because del phi by del y and del phi by del z is 0, because there is no y and z in the expression of this phi. So the partial derivative of phi with respect to x is 2x, and uh, we have the unit vector I cap multiplied with it. So this is the vector, uh, this is the gradient vector at each point of this function, which will give the direction of maximum rate of change at that point. So we will put a point x is equal to 2. So at x is equal to 2, phi is equal to 4. So here this point. So at for x is equal to 2, the gradient of function is, uh, you can see 2 times x means 2 into 2 4, that is 4 I cap. 4 I cap means it must be like this is 4 I cap. So you can see the vector is pointing in this direction. So what does it really mean? It means that when you will go in this direction, you will get the maximum rate of change. You can see as you move in this direction, the function is changing rapidly, and the rate of change is very high here. So this is how the gradient operator operates on a function and gives the gradient vector at each point, which gives us useful information about where the derivative is high, in which direction it is high. So this is about gradient.